This webinar is sponsored by the Federal Highway Administration and hosted by the National Operations Center of Excellence, also known as NOCO. As a quick reminder, if you don't know already, at NOCO, we offer a variety of resources to support the transportation systems management and operations community. On the lower right side of your screen, you can see a box called Useful Links. You can browse through these for TSMO resources and news. Previous webinar recordings related to this topic can also be accessed from there, as well as today's slide deck will be available there. All the attendees are in listen-only mode by default, but we'd like you to stay engaged by using the question and discussion pod for comments and questions. We will have a Q&A session at the end of the webinar, so if you have any questions, we encourage you to enter them in the Q&A pod as they come to your mind at any time. The questions will be read out loud one at a time by the moderator, and our presenters will answer each question. So that's all I have, and with that, I'll hand it over to our moderator, Nicole Pallado, to start things off.
Thanks, Kevin. Good afternoon, everyone. My name is Nicole Pallado. I'm a communications specialist with Leidos, and I will help to moderate today's conversation. Before we get started, I'd like to introduce our speakers. With us today is Paul Joden, Traffic Incident Management Program Manager at the Federal Highway Administration, Yinyan Liu, Associate Professor at Arizona State University and Visiting Scholar at FHWA's Saxton Transportation Operations Laboratory, and Sujith Racha, Program Manager at Saxton Lab, overseeing the Cooperative Driving Automation Research Program. Please feel free to continue introducing yourselves in the chat pod. And quickly, we have a quick disclaimer. This presentation was created and is being co-presented by both FHWA and a contractor. The views and opinions expressed in this presentation are the presenters and do not necessarily reflect those of FHWA or the U.S. Department of Transportation. And with that, I will hand it over to Sujith to get us started.
Thank you, Nicole. Good afternoon, everyone. I'm Sujith Racha, and as Nicole said, I'm the Program Manager for the Federal Highway CDA Research Program that's being performed in Saxton Transportation Operations Laboratory. The project we are speaking today under this program deals with transportation system management and operation TSMO use cases and using CDA research. And one such tool that we are going to talk today is a traffic incident management benefit cost tool, which helps identifying or navigating through PIM traffic incident management scenarios. And the tool is developed by Federal Highway a couple of years ago. However, we want to bring that to life and make some enhancements in order to make it much more user-friendly for the industry. With that, today we are going to talk briefly about the overview of the project objective and the approach we are taking and where does the tool stand today. We are also going to provide you with an overview of the tool with the modules that are included as part of the tool. There will be a demonstration with a web link or a web interface that we are going to showcase to you guys and seek feedback from you and incorporate the feedback to enhance the tool. We are also going to talk about the benefit and cost estimation methodologies. And based on the feedback that we have received, we want to make some improvements to the tool and talk about next steps. With that, I'm going to hand it over to Paul Jordan to provide some opening remarks for our team community.
Thanks. Thanks very much, everybody. Appreciate everyone's participation today. Looks like we got a great group and not so many of the of our usual characters. So a lot of new names, which is great. That's what we love to hear. So I'm going to give a little background behind this benefit cost tool. So You know, in the traffic incident management world, you know, things that we do are really not tangible, right? Sometimes they are. If there's a big crash, we get it cleared quicker or something like that. It's tangible. But most of the things is really not something that people understand the benefits. If we had one less secondary crash, people don't understand that, right? So if we made the scene more efficient and thus cleared the roadway 20% faster, we helped out a lot with congestion, but no one really knew that we did that. So, you know, when you're a police officer and you arrest somebody or you do a big drug bust, it's tangible. People understand that. You put out a house fire, same thing. The fire, you know, people, the citizens understand, you know, okay, we need to fund the fire department because they put out fires. And same thing with roads and bridges and, you know, construction and ribbon cutting and all that. So everyone understands that piece. But what we do is tangible, is not as tangible. So we think there's a value, and we did a number of years ago when we first had the concept of this project, that we need something to, you know, beyond the performance measures and the data collection that we do, to sort of show the benefit of the various strategies with TIM programs. But it started with, you know, years ago. You know, I think it was maybe around 2012, 13, 14. There was a lot of interest in you know, budget cuts, and the first thing that budget people wanted to cut was this nice little service that we provided called service proposal. Why are we giving this free service to people, giving free gas and changing tires and this and that? So, of course, there was a fight, and it didn't happen everywhere, but it did happen in some locations, and actually we lost some programs. Some we gained back, some we didn't. And it's still happening today, but not to a lesser degree. So it was quite a long project, a lot of simulation scenarios that we finally got, after recommending a project, a benefit cost tool for safety service patrol. But the managers had recommended that they, you know, we can use this for other strategies as well, and you'll see those in a minute. And you know, and they asked me what are the things that, you know, other strategies, and I said, well, TIM committees and you know, move over laws and things like that. So I'm not sure that those are the right strategies, if those should be changed, or if there's even any value in those. But we know the service patrol for sure is constantly under attack by budget cutters. So we need to be able to point to something where the benefit and the cost match up. So this, even though that was the TIM team, Jim Ostrich, currently Joe Tebow's with us. Even though it was our project initially, you know, the research office at Federal Highway, Turner Fairbank Highway Research Tech Program, you know, took it over for us because that's not our expertise, and developed this tool. It's pretty good. We got some input then. We think it has value, but Jim Ostrich and I fell into some money some months ago, some leftover money, and we said, look, at that tool probably should be updated and having another look at it. And so we've been talking to Turner Fairbank, and you'll hear from the manager, and we like your input. If there's anything of value that you know that you have to offer us via recommendations to make the tool better, I think there's some folks on the line here that understand the program probably better than we do, as far as the data and the you know, the benefit cost tool application. So with that, I'm gonna stop talking. I didn't read the slide there, but you guys can read. I'm going to ask if my partner in crime, Jim Ostrich, you have anything you want to add, Jim?
No, Paul, thanks for asking. I think you covered it well. Look forward to the feedback today. Thanks.
All right, sir. All right, sir. So with that, I think my responsibility is to pass it on to Ying Yang Wu. Right? Yeah.
Thank you, Paul. My name is Yingyan Lo. I am an associate professor at the Arizona State University, specializing in smart transportation, and a visiting scholar at the Saxton Lab. As Paul has explained that this tool the TIM-BC tool was developed around the 2015 timeframe, and we are currently working on a project to, in fact, bring the tool back to life and improve the tool so that it can be more useful for the communities. And I am leading this effort to improve the TIM-BC tool. So very happy to be here today to provide an overview of the tool, walk through the tool with all of you, and talk a little bit about the inner workings of the tool. So in order to raise awareness of the tool and identify potential improvements, the project team at Saxton Lab has taken the following approaches as seen here on the slide. Webinars, interviews, and workshops will be carried out with stakeholders to seek stakeholder inputs. In fact, today's webinar is our first event with the goal of learning about the tool. Stakeholder interviews and a workshop to discuss potential improvements are planned in the next several months. And in addition to providing the TIM-BC software for the TIM community to use, we also made the source code of the software open source and has been published for researchers and developers who may be interested in customizing the tool. New and improved documentation has been developed and published for end users, researchers, as well as developers. In the useful links section, we have posted 3 links: the link to download the software itself, the link to the source code, and the link to our Confluence space where all of the documentation is published. As I mentioned earlier, in the rest of this webinar, we will first provide an overview of the tool, followed by a walkthrough and a live demonstration of the tool. I would like to encourage the audience to download the tool and follow along during the live demonstration portion. After the live demonstration, the inner workings of the tool, namely the benefit and cost estimation methodologies, will be discussed. And then we will conclude the webinar with next steps in this project and ways for the audience to engage and contribute to this effort. So the TIM-BC tool, this is the landing page of the TIM-BC tool if you launch it. It allows users to perform benefit and cost estimation for a range of TIM strategies. Currently, the tool has implemented benefit cost methodologies for 8 strategies as shown here in the figure. Paul also mentioned that there are multiple modules here, including safety service patrol, driver removal laws, authority removal laws, shared quick clearance goals, etc. 4 types of benefits of TIM strategies are estimated, including travel delay, fuel consumption, emissions, and secondary incidents. These benefits are estimated both in their native units and monetary equivalents. The tool is very simple to use. It requires less data than some of the other tools. And the BC methodologies implemented in the tool are standardized and can be applied universally to all of the 8 supported TIM strategies. The tool can be used to assess proposed expansion of existing TIM programs, assess the value of creating a new TIM program, or compare alternative TIM programs. So next, I am going to first walk through the tool following along some slides that we have already prepared. And after that, I will demonstrate how to use the TIM-BC tool in a live session. Installation of the tool is a breeze. Users can go to the first link provided in the Use Link section, or this link shown on the slide, to register and download the tool as a zip file. The zip file is named TIM-BC tool v2.zip. Once the zip file is downloaded, simply unzip the file to a folder of your choice, and that completes the installation of the tool. To launch the tool, navigate to the folder where the unzipped files are saved, and double-click the shortcut named Launch TIM-BC Tool as highlighted here in the figure on the slide. And that will launch the TIM-BC tool and bring us to the landing page of this tool. We've seen this before. This is where all of the 8 supported TIM strategies are listed. So from here, users can choose the relevant strategy that their TIM program of interest falls into in order to launch the relevant module where user inputs will be collected and benefit cost estimation performed. Once a module for a specific TIM-BC strategy is launched, the tool will walk the users through a total of 5 pages. 4 of those pages are for user inputs, and the last page is for results. So here on this slide, we're showing an example home screen of one of the modules. This happens to be Safety Service Patrol. This home screen is the first page of any module. On this page, users can choose to start a new TIM-BC analysis project or load data that has been previously saved from an existing TIM-BC analysis project. Pages 2 and 3 of any module are shown here. If we start a new project, then page 2, which is shown here on the top, in the top figure, will be shown. And this is where users are prompted to name the analysis project. On page 3 of the tool, which is shown in the bottom figure here, users are asked to enter project level information, such as the state, the number of roadway segments the TIM program of interest is applied to, the study period of the benefit cost analysis, and the annual total program cost. The 4th page of a module is where users input detailed data of each roadway segment in this TIM program of interest. 5 groups of data are required. The first group is general segment information, as seen here in the top left portion of the screenshot. This includes segment name and the region. Right below the general segment information is the box for roadway geometry information, and this includes length of the segment, number of ramps, number of lanes, terrain information, and horizontal curvature information. Moving on to the middle column, at the top of the middle column is the input box for the TIM program of interest itself. Users are required to select the operation times of the TIM program, times of day. There are 4 options, AM peak, PM peak, etc. And provide estimates on the percentage of incidents whose durations will be affected by the TIM program, as well as the average reduction of incident durations due to the TIM program of interest. At the top right column is the input box for relevant incident data for the segment. This includes number of incidents and average incident duration, broken down by lane blockage. Secondary incidents as a percentage of primary incidents is also a required user input. Finally, at the bottom of the middle column, users are asked to provide traffic and weather information for the segment. The color of the header of each of the input boxes indicates whether minimum data requirements have been met or not. When all data required has been entered, the header of the boxes will turn from blue to green. At this time, users can click the Calculate Ratio button to compute the BC estimates. The results for the benefit cost analysis for the entire TIM program of interest are summarized on this last of the 5 pages of any module of the TIM-BC tool. If users are interested in segment-by-segment results, segment-by-segment benefit cost estimation results, Those are also provided in a final report in PDF format that can be generated by the tool. So this concludes the simple overview and quick walkthrough of the tool. Next, I'm going to go ahead and demonstrate the tool in a live session. Again, I encourage all of the audience to download the tool and follow along. Here is the folder that I have chosen to install my TIM-BC tool. It is simply by unzipping the downloaded zip file from the TIM software download page that I created this folder. And in this folder, the Launch TIM-BC tool shortcut is how a user would launch the tool. But I would also like to point out there is a folder called Example Test Cases, where certain example analysis projects are provided. So users, if interested, could load those data to see what the results look like. So double-click the Launch TIM-BC tool shortcut. This brings us to the landing page. And this tool is actually web-based, but all the required data and calculation are included in the tool installed on the local machine. And here are the 8 modules for the 8 TIM-BC strategy, for the TIM strategies that are supported by this TIM-BC tool. Choose one of the modules that's closest to the TIM strategy or the TIM program of interest that you're analyzing, and click the Launch button to launch the tool. And this is the home screen, the first of the 5 that we have talked about in each module. So on this module, we can start a new project, enter project name. That's page 2 of the tool. The next page would require user to enter project level information, including state, segments. I'm going to leave state as default, but a drop-down list is provided for users to choose their state. Number of segments is the number of roadway segments that the TIM program of interest is being applied to. For this demo, I'm going to use 2 just to show that later that we can copy data from one segment to another. That saves a little bit of time of manually entering everything. Study period duration, I'm going to leave it as 12 for this demo. And the last box here, input box here, is the annual total program cost. For SSP module, there is a feature in this tool to calculate the program cost using detailed user inputs. And this is what the detailed user input page looks like, where users could enter patrol vehicle type, going to just enter some simulated data, say 5 trucks, hourly rate for drivers, working hours per day, and working days per month. If you needed to run these vehicles, patrol vehicles, and the provided gas, which is for the SSP program, this refers to the gas that the program is giving out to drivers of need, to drivers in need. And vehicle maintenance, other costs. So the tool, as users input these detailed breakdown line items for the safety service patrol program, the monthly total of each type of patrol vehicle involved would be calculated, plus the annual fixed cost that would be the annual total cost. For other strategies for the rest of the 8, except the SSP, the annual total program cost is simply a lump sum user input. From here, we can move on to the segment input page, which is the fourth page in the tool. I would also like to highlight that with this 4-bar icon on the top left corner of this tool, users can jump from one page to another, given that required information has been initially entered at some point. So for segment information, currently, I'm working on segment 1. Since this analysis project includes multiple segments, a user could choose which segment, could choose the segment that is being worked on from the segment dropdown, enter the segment name, select its region. We're just going to select, since I believe the default that I have used for this demo project is in Alabama, I'm just going to choose Birmingham, Alabama region. This information, the state and the region information, is important because publicly available data on average gasoline price, labor cost, etc., will be used for this area. Will be used to calculate the benefit and cost analysis. So for roadway geometry segment in miles, number of ramps, leaving it at 0 for now. Number of traffic lanes by direction. If we change the lanes here, we can see that a prompt will show up showing that changing the number of lanes will reset the blockage values, which is actually referring to the incident information box. Because when we have 3 lanes in this segment, the incident information box will be updated to prompt users to enter the number of incidents for each type of incident in terms of roadway blockage. There are 3 types, or if there are 3 lanes in the segment, then the required information will be number of incidents of shoulder blockage only, number of incidents that block 1 lane out of the 3, number of incidents that block 2 lanes out of the 3. This TIMBC tool does not handle incidents that lead to full closure of a roadway segment. And that is why we do not see here a line item for incidents that block the entire road freeway, in our case, the roadway. In our case, blocking all 3 lanes. Again, if we change the number of lanes here, the incident information block will be updated. I have changed the number of lanes from 3 to 4, and at the end, the line items here, there's one more that has to do with incidents that block 3 out of the 4 lanes. Moving on to the rest of the roadway geometry segment. General terrain, there are 4 options: flat, level, rolling hills, and mountainous. Horizontal curve, also just 3 categorical values: straight, mild curves, and sharp curves. And this is part of the feature of the tool where the required input data is not as intense comparing to many of the other tools out. So instead of requiring detailed curvature in terms of degrees, the user input required for horizontal curvature is by category. And as we can see, the roadway geometry box now has been completed, This is indicated by the header of the roadway geometry turning from blue to green with a check mark next to it. The next box is the program information for the Safety Service Patrol program that I'm analyzing right now. And again, pointing out that the header of the Sspc program currently is blue, meaning minimal information required has not been completed. Operation time, choose the appropriate time of day that the TIM program is being operated. It is possible to choose multiple, and if we choose multiple operational time periods, then the incident information will have multiple time periods that require user inputs, as well as the traffic information. For this project, I'm assuming this TIM program operates during both AM and AM peak, and as a result, traffic information for AM peak, PM peak will be required, as well as the incident information for AM peak and PM peak. Incident duration savings, this is a very important input for this TIM-BC tool, and we'll come back to this and why this is important in the next section where we discuss the methodology, the inner workings of this TIM-BC tool. But for now, it is worth mentioning that there are two ways of entering the duration savings. This is user inputs. We can choose average duration in minutes. This is average across all the incidents in terms of their severity, meaning lane blockage. Or we could choose to enter incident duration savings by lane blockage. And if we choose by lane blockage, then additional input fields will show up in the tool to ask for this detailed input. Whereas if we choose average duration, then this is just a single number across all the types of lane blockage. So for now, I am going to show this more detailed inputs by lane blockage. Make up some numbers here. And this input relies on local knowledge of the TIM program. Moving on to the traffic information section. 65 miles per hour is the main lane speed limit. And during AM peak, the volume is 2,400 vehicles per hour per lane. And that is, in fact, outside of the range of the TIM-BC tool. The reason is because the tool is designed to not require intense user input data. The methodology is developed based on simulated data. And the simulation scenarios for traffic volume, in fact, varies from 500 to 2,200. And that's why it wouldn't take an input beyond that range. Peak PM is heavier. Truck percentage is 10 and 5%. Just making up numbers here. And weather type. Regardless of how many types of weather is chosen here in the tool, it has to add up to 100%. 5% is clear. % is clear. So now the weather information is checked out because all types of weather add up to 100%, and the entire traffic information box is also checked out. And finally, the incident itself, number of managed incidents. This is referring to number of managed incidents by this TIM program that you're analyzing, in this case, the SSP. Number of managed incidents, let's say, again, this relies on local knowledge. And an average incident duration is I'm going to, again, make up numbers for the PM peak. And finally, secondary incidents, let's say 10%. Again, another important user input relevant to the benefits estimation of secondary incidents. So that concludes the fourth page, the segment information input for segment 1. And we can save data, save project data just to be safe, not to lose this input. When project data is saved, it is saved as a JSON file, which can be loaded using this button. Now, I've entered information for segment 1. For segment 2, let's say they're similar, or there are some minor differences. So a user could, in fact, copy, delete the segment 2 and copy data from segment 1. This way, I don't have to start from scratch. Instead, the segment 2 data is pre-populated using segment 1 data, and users could, from there, adjust the values as necessary. From there, all data required has been entered, and we can calculate the benefit cost ratio. This is the last page of the 5 pages of each module, and the benefit costs for the entire program. The entire TIM program is summarized here. Users could produce a PDF report by clicking this button, which will provide detailed explanation of these benefit cost results, as well as segment by segment results. That concludes the live demonstration. And coming back to our webinar slides. So now that we have seen how to use the TIM-BC tool, in this section, we'll discuss the computation engine under the hood that provides all the BC estimates. Benefit estimation is the key here. Cost estimation is simpler compared to benefit estimation. So the majority of this section on the best benefit cost methodology will focus on the benefit estimation. Benefit estimation in the tool, in the TIM-BC tool, is based on the assumption that most benefits of a TIM program would originate from the reduction of incident durations. And this includes travel delay, fuel consumption, and emissions. Improvements of these benefit measures are calculated as a function of incident duration reductions. And therefore, information regarding incident duration reduction is important, is a very important required user input. And this includes, as we have seen earlier in the demo, the average incident duration reduction, either as a single number averaging across different severity levels in terms of lane blockages, or detailed incident duration reduction by lane blockage. For other strategies, on this page we're showing an example of the driver removal law, TIM strategy. For other strategies, the TIM program, for example, driver removal law, would not necessarily apply to 100% of the incidents. The driver removal law would only apply, for those of you who may not be familiar with that, to incidents that block one lane. The assumption here is for incidents that block more than one lane of the roadway, the incident would be severe enough and the drivers are assumed not be able to remove the vehicle to the shoulder of the road by themselves. So for certain strategies, like driver removal laws, inputs on percentage of incidents whose durations are expected to decrease due to this TIM program is required. And that is highlighted here in this box titled Applicable Incidents. The TIM-BC tool will take these user inputs on average incidence reduction, on the incident information and secondary incident to compute the outputs, which would be overall estimates in terms of travel delay, fuel consumption, emission, and secondary incidents. For travel delay and fuel consumption estimation, the benefit estimation methodology is built on data analysis, results from hundreds of thousands of microscopic traffic simulation runs using a simulation model calibrated with Maryland freeway data. Various scenarios with different combinations of incident and environment characteristics are simulated in order to associate the total delay and fuel consumption with incident durations, as well as other relevant variables. Emission estimation is based on fuel consumption, estimating using data from U.S. Environmental Protection Agency. More specifically, a set of regression equations for travel delay as a function of incident duration is developed from simulated data. The equations are shown on this slide. As can be seen here, in addition to incident duration, variables contributing to the total travel delay also include percentage of lanes blocked by the incident, free flow, speed of the roadway segment, volume, grade of the road, as well as percentage of trucks in traffic. For fuel consumption, a hybrid statistical simulation approach is adopted in the TIM-BC tool. This approach uses second-by-second vehicle speed and acceleration profiles from the simulation to compute fuel consumption. This simulation-based computation is done for incident scenarios on a flat road with no trucks and produces a lookup table. This lookup table is then combined with a regression component to account for percentage of trucks and the roadway gradient. From fuel consumption, emissions are then estimated using emission factor and fuel economy data obtained from US EPA. And finally, publicly available data, as shown in this table here, is used to compute monetary equivalence of the estimated benefits. On the cost side, we've already touched on that. The TIM-BC tool takes a lump sum value for the annual total program cost as a user input for most TIM strategies, with the exception of the Safety Service Patrol tool, where users can input detailed line items. The tool then calculates program cost for Safety Service Patrol program using the user inputs. This concludes the methodology overview section. As we mentioned earlier at the beginning of this webinar that the goal of this project is to actually improve the TIMBC tool by seeking user inputs and seeking user feedback. I will now hand over to Paul to discuss the next steps in this project to improve the TIMBC tool.
Okay. So the next steps are, we want your, I guess we want to, this is the wrong slide. Was there another slide? We want to be able to get your input. And there's some questions in the chat pod that I'll let the experts. But we want to have it a little bit different tool, and we want to have it open-end sources, which is a big deal, so that researchers and developers and that they can really utilize the software and many of the other items. We're going to be sending you an email in January for some feedback. I know many of you are shy, but you'll have to get over this and give us some feedback. We really want to make it a useful tool. We think it was a useful tool when it was originally developed, but we think we have some more some more room for improvement, and certainly technology and things have improved. So stay tuned for that. But typically we work with Jim and I work with TIM program managers and engineers, but I think there might be a wider group that we're looking to engage here. Researchers and developers, software developers, and some scientific and other people, non-traditional partners, if you will. So we certainly recognize that there's some smart people out there that can provide input. And with that, is that what I was supposed to cover? Now we'll go to questions, right? So that would be, Nicole is going to facilitate the questions.
Sure, yeah, so we've already gotten a lot of questions, so I'll just go in order to make sure that we address as many as we can. Our first question is just clarifying. Someone asked, am I accessing the correct web pages and files? I'm seeing version 2.0 of the tool and associated user guide from 2015. Is that correct?
That is correct. The tool was last developed in 2015, and we just started this project to improve the tool. So the user guide is from 2015. I would encourage all the audience to check out our Confluence space, where all the documentation has been published, including documentation from 2015 when the tool was first developed, as well as new documentation to clarify what wasn't very clear in previous documentation, and also new documentation for researchers and developers.
Yeah, I'll just add that, we're saying it's developed in 2015. It was really earlier than that. That's when the tool was formally approved and posted. So it was probably a couple of years before that the tool was actually in development and finally approved for development in 2014. So it's old, and but we think it still has value, and we think that there's an opportunity to even improve it further.
Great. Our next question is the tool useful for analyzing specific incidents or just intended to be used for program level questions?
The tool is intended to analyze program level benefit cost.
Okay, next question. Using this tool for SPP, we have gotten high outputs in the double digits. The example output looked like a benefit cost of 18 to 1. Is that normal or average using the tool in your experience?
So the example demonstration used artificial data that I made up. So the cost probably is not very realistic. Depending on the number of incidents, certainly the TIM strategies could be very cost-benefit effective, but I would not say that it will necessarily be as high as 18 to 1. However, I would also like to invite experts in the TIM community who have done some of the benefit cost work for your TIM programs to also chime in on this question.
I will just add, and some of my friends on the call will understand this. Hearing me say this before, if the numbers work in our favor, go with it. So it's sort of a joke, but you know, it probably isn't that outlandish. And I'm not a data guy, so I'm just a simple TIM guy. But you know, there's a lot in play here when the road is blocked, right? We all know that, you know, all the elements that are included in the tool, you know, there's probably more elements that actually have an impact than that. So I'm going with 18 to 1 myself.
Okay, our next question. Will the monetary values be updated to 2020 or 2021 in the output report?
That is a very good question. This is one of the potential improvements that would be very straightforward and necessary. And currently, nothing has been updated yet, but we are starting to work on a list of potential improvements, including on the data side, and as well as on the methodology side. This is a great suggestion to update the monetary values. Also, any of the data that has to do, that is used in the TIM-BC program, any of the publicly available data could be updated as well. And we do plan to implement selected improvements in the time frame of early 2022. So there will be an updated version of the tool published around April-May timeframe with improvements. And we expect to have improvements such as data updates in the updated version.
Okay.
Hey, if I could just chime in again there. Yin-Yang, is there a way to you know, keep up with that as we manage the tool? Is there, you know, some index or some, you know, basically automatic updating that can occur a couple of years down the line, or is that something we need to change every year or two? Because I know that we discussed that years ago, and I thought there was some sort of automatic function that could occur, and I guess not, though.
Thank you, Paul. This is a great suggestion as well, one that we have also started to think about. To perform the automatic updates, as you suggested, the tool itself probably would need to be, major updates probably need to be done in terms of the software architecture of the tool, so that the tool could be querying publicly available sources and pull the data in on the fly as TIM program BC analysis is being performed. So it is certainly a possibility, but one that's as part of this project that we will investigate. What are the possible ways of improving the tools, and what can be implemented now, and what should be implemented further down the road.
Okay, great. Moving on. So our next question, are administrative costs for the SSP accounted for?
This is where users could include their admin cost for any of the TIM programs in the fixed annual cost. This would be a user input.
Next question, if you want to perform a sensitivity analysis increasing the total fleet operators, the cost increases on the segment input, is the best way to adjust for the increase in patrol to increase the incident savings, or what do you recommend?
This is a really good question. I can see a couple ways of adjusting the potential benefits or outcome of the program where multiple or more vehicles will be included in the safety patrol program. One of them will be the number of incidents managed. In the SSP tool or in the SSP module, the number of incidents and the duration of incidents as user inputs are actually specific to incidents managed by SSP. In other words, the number of incidents that the program would actually help, not necessarily the number of incidents that typically occur on the freeway. So adjusting that value would accurately reflect how the increased fleet size would benefit more incidents, would be able to apply to more incidents. So that's SSP. On a related note, for other team strategies, for example, driver removal law or authority removal law, the percentage of applicable cases could be adjusted to reflect what the law actually says. And compliance rate can be adjusted to reflect any marketing campaigns that may be carried out to raise public awareness. For example, there are, say, 10% of incidents that could potentially be removed by drivers themselves, so fender-bender type. And then out of the 10%, not all the drivers will follow, will actually remove their vehicle from the lane to the shoulder. Let's say before the driver removal law, the compliance rate is 2% or 20%. So 2 out of the 10 fender-bender incidents will actually be resolved by the drivers themselves removing the vehicle to the shoulder lane. After the TIM program, depending on what the expected outcome would be based on the effort in the public awareness campaigns and such, or even there might be fines or things like that associated with it, the compliance rate could increase from 20% to, say, 50%. So these are the types of inputs that would affect the final benefit estimation. On the other, coming back to the SSP, the question is specifically for SSP. I mentioned that the number of incidents managed would likely increase as the size of the fleet increases. The question also mentioned that the duration saving, the incident duration reduction, would that potentially reduce as the size of the patrol increases? I think this is a possibility. Again, this is very case by case. If the patrol size is, let's say, doubled, and then the new program operates a little differently than the previous program, where the patrol vehicles are just going to go run in pairs, then it is possible and very likely that the reduction will be higher in terms of incident duration, because you would have more personnel, more equipment to deal with the situation at hand. if the program simply increases the fleet size to be able to cover a larger area, more freeway segments, then the benefits increase would be more reflected in the number of incidents handled than the average duration reduced. I hope that makes sense.
Great. Moving along, next question is, how is the traffic rerouting effect taken into consideration in the model?
Great question. For this current version of the tool, I believe the rerouting is not considered, and that is partly why the incidents that block the full roadway, all the lanes on the roadway, are not considered in this Sspc analysis. So the freeway or the roadway is always going to have remaining capacity in this tool so that the traffic could go through. But this would be something that we could look into in future updates in terms of methodology. But then again, if that is the case, the required data would be, it would be a lot more data required in terms of potentially the topology of the network, of the area, and other roadway geometry, etc. information that could be too intense and render the tool a little less useful for TIM program managers. But this is a great suggestion that we could start looking into and see how to balance the capabilities of the tool in terms of new methodologies and new scenarios that can be handled by the tool, and balance all of that with the usability of the tool.
Great. Next question, is there a way to validate the output from the tool?
I would think that to validate the results would require a data collection for before and after Sspc program implementation. And the only validation there would be, the only validation that is meaningful would be to validate the results with actual data. And I believe there is a national initiative on collecting before and after data of TIM programs, and Paul and Jim may be able to speak more on that.
I'm sorry, I didn't get that question. What was that? I'm sorry.
Oh, no worries, Paul. I was referring to the national initiative on data collection of TIM programs.
Well, we have a couple of other initiatives, right? We have the annual self-assessment that we collect data from, well, this year, over 100 locations submitted. And but we also have our TIM performance measures that we measure, about 4 different recommended measures that we recommend that we're working with states to collect. One is roadway clearance time, first recordable awareness to when all lanes are open. The second one is incident clearance time. It's basically when all first recordable awareness, when everyone left the scene, right? That's different. If everyone clears all the lanes but still on the side of the road, it's still having an impact on safety and throughput. So, and then the third measure is number of secondary crashes, and then we have another 4th measure that's been added in the last year or 2 on a responder struck by that's on the crash report. So, so there's 2 different other mechanisms for collecting the you know, how well TIM programs are doing throughout the country. Hope that answers the question.
Well, thank you, Paul. Yeah, I think it's good to know that there are national initiatives on data collection for TIM programs, and the data collected could be used to validate the TIM-BC analysis results.
Yeah, could absolutely. For example, if in those areas that are collecting secondary crashes, for example, you know, you don't have, a lot of areas don't have that, so you sort of have to guesstimate what the impact of secondary crashes are. But if there's solid data, instead of using the 10%, maybe it's only 5%, and that's because there's no solid national number, for example, on any of the TIM performance measures, but in particular. Secondary crashes. Back when we estimated the tool, you know, we were throwing around numbers like 10 and 20%, and I don't think secondary crashes is that high on a national level, and likely not in your region. It could be more like 5% or 7% or even 2%. So, but having those numbers would, you know, that are collected through other methods would obviously make the benefit cost more accurate.
Great. Next question. Can you explain the relevance of the number of Rants in the benefit cost assessment?
Yes. Thank you for the question. I believe the roadway geometry, including number of ramps, terrain, and horizontal curves, are taken into consideration in the analysis tool by adjusting the free flow speed. So all of these factors will have an effect on the actual speed of the traffic. And the speed of the traffic is actually a variable in the calculation of the total travel delay. It's in the regression equation as an input variable. So the number of ramps, the terrain, and the curvature are all taken into consideration through the speed. And details on that can be found in the project report, which is linked in our offline space. And also on the tool itself, if you click on the icon with the eye in it, that provides some high-level explanation of what this input is. For example, in terms of terrain, there are 4 values possible: flat, level, rolling hills, and mountainous. And the flat terrain will not have an effect on speed, so speed will not be adjusted. If it's level, then the travel speed will be adjusted as free flow speed -2. If it's rolling, then it's free flow speed -5. Mountainous is free flow speed -10. Again, detailed information like that can be found in the project report as well as in the tool itself by clicking the icon with the eye in it.
Okay, next question. Can you explain any considerations that should be taken in defining segments such as roadway geometry or incidence for the Sspc analysis?
So the tool assumes all the segments are homogeneous segments in terms of roadway geometry. So if the number of lanes change, that should be a new segment. If the terrain changes, that should be a new segment. If the curvature changes, that should be a new segment. So if you have a highway that is on the same terrain, flat, 3 lanes on each direction across, but you have a straight segment followed by a horizontal curve, and that should be broken down into 2 segments.
Great. We have a couple final questions. Do you use University of Maryland CAT lab data?
I believe this is referring to the INRIX traffic data, or is it referring to the incident data? But regardless, I do not think that when the tool was developed, I do not think it used any of that data. All the equations and methodologies that are built in the tool are derived from simulation data, where the simulation model itself is developed, of course, based on many good references and on how to handle the possible speed reduction and bottleneck and rubberneck effect, etc., of relating to an incident. And again, I would like to thank Shelley for bringing this question up, and this is something that we would add to our list to discuss for potential improvements.
I would just add that the simulations were actually done by the University of Maryland. They were actually subs that did the bulk of the simulations, thousands of simulations, maybe more than thousands. But I'm not 100% confident in saying it was the CAT lab that did it. It was someone. It was definitely the University of Maryland, though. Nicole, you still there?
Yep. Just looks like some folks are in the middle of crafting some questions, so I'm just pausing for a second.
Oh, sorry.
Some more roll in. No
Didn't know if we lost you there. Don't answer any more Jeff Kaufman questions. Yeah, just joking. Just joking. He's an old friend from Houston.
Looks like kind of a comment question. It would be especially helpful if the traffic volume calculations were performed in the background. If we're already entering the number of lanes per segment and the volume, it would be great if the application handled the information listed.
Noted. And we appreciate all the inputs. And again, please do download the tool, play with the tool, and reach out if you have any questions. You can leave a comment on our Confluence space. The link of that is posted in the useful links section. I'm not sure if that's still visible to the audience here in the meeting room, but if not, that will be sent out as well. You could also send an email to, I believe, Saxton. I'll let Nicole tell you all about the email address if you have any suggestions or questions. And we're going to take notes from today's webinar and add all of those to our discussion points for potential improvement. And I do see a couple small questions, minor questions on the tool, the launch the tool. That shortcut is not working, and you do have to unzip the file instead of just clicking on the zip file and in the preview clicking the tool. So the step of unzipping should not be skipped. So extract all the files and then click that shortcut. That should work. And any website for further information. We have all the information published again on our Confluence space, and the useful links box, I believe, is now visible. And that on the Confluence, in our Confluence space, we have summarized important information from project reports in the past, from our own exploration of the tool, as well as new documents that we have developed for developers and researchers. You will also find links to the user guide and the project report, again, from when the tool was first developed.
I think we have one final question. So someone asked, if you split one segment into two due to a horizontal curve, what if the length of the horizontal curve section is very small compared to the overall segment length? Does it matter if the segment is being designated as horizontal curve?
That is a great question. I would think if the segment length is very small, it would not probably matter that much. The tool does allow you to enter a small number in the segment length box, but if the segment itself is very small, then the number of incidents on that segment would also be likely negligible.
Fantastic, and it looks like that's our last question. Thank you everybody for attending today. Please use the helpful links, and I also linked the Saxton Lab email where you can send any further questions or comments if you think of anything after the webinar today. But thank you again for attending.